Okay, so our last little bit is some practice of all of the reactions that we've done, as well as a little bit of naming. So it asks you to draw the name of the ester formed in each of the following. So take a moment and see if you can figure it out. And the next slide too, if you want to. And I'm going to go ahead and go through these answers. Let's do red. Okay, so the ester formed in each of the following. So we're doing an esterification reaction. We're going to flip-flop the oxygen portions of each of these. So the alcohol and the OH flip-flop places. So we have our long carbon chain. And then this is where we're going to flip-flop. Maybe let's, that's fine. That's where we're going to swap. So now the alcohol is attached to where the carboxylic acid was. And then we have plus water. The name of the following. So in order to do that, let's go ahead and name our starting material. So we have 1, 2, 3, 4, 5, 6, 7 carbons. So heptanoate, heptanoic acid. There we go. And then we have our alcohol, which is isopropanol. Okay, so our name of our ester is going to be isopropyl, which derives from our alcohol, and then our carboxylic acid portion in the carboxylate name. So now we have heptanoate. So remember, to do that, you just drop the IC acid and add ATE to the name. And that gets you there. So isopropyl heptanoate is the answer for this esterification. Okay, so let's try another one. I'm going to go ahead and name these to just start with, because why not? So we have benzoic acid. And then we have our alcohol. So for our alcohol, let's do orange. This is not quite as simple of an alcohol, right? But we can still name this alcohol. We know how to. We have 1, 2, 3 carbons. So we have propanol. 1 propanol to describe where that alcohol is. And then we have 2 chloro. Okay, so now that we've named these, we're going to, let's just circle what we're flipping. So we're swapping these guys out, the OH and then the OR of the alcohol. Let's define that a little bit nicer. The OR are flipping, the H is staying where it is. Let's do the same thing up here. The OR is what's swapping with the OH of the carboxylic acid. Okay, so then we draw our product. I'm going to do a mix of colors for this one. We have our benzoic acid portion, and then we're going to add our alcohol on there. I just flipped that around, just spun it around so that I could keep my zigzag going the right way. Okay, so that's going to be my product. This is a pretty tricky one, guys, because there's a lot of weird parts. It's not just straight carbon chains. But let's go ahead and try and name it. So the first part of the name comes from the alcohol, and then we just eliminate OL and add, eliminate ANOL, we add YL instead. So the beginning of this name is going to be 2 chloro, 1 propyl, and then we continue with the carboxylic acid portion in the O8 or 8 form, so the carboxylate form. So we're going to put ATE at the end. So then the end is going to be benzoate. 2 chloro, 1 propyl benzoate is the final answer. That is a mouthful. Okay, our last couple practice problems. Draw the products of hydrolysis under the conditions shown. I also forgot to write water. How dare I? That's okay. Okay, draw the products of hydrolysis under the conditions below. So this first one, we have acid because we have H plus. We have our water and heat. So we're going to break apart this ester. So I'm going to draw this line here to show where I'm going to break it apart. You can also draw those circles to show where you're going to break it apart. Actually, I kind of like the circles better. Let's do circles. So I'm going to draw out water so that I can show where I'm switching. So I'm going to switch these two with these two. Okay, so then we have, if we break this ester apart, we're going to have our carboxylic acid, which is one portion, plus our alcohol is the other portion. Okay, and that's the answer. That's all we need to do. Okay, and then our last one, let's go ahead and draw out KOH as well. So we're going to draw HO minus and then K plus. So I'm going to circle the OK plus and then the OR group, and these two are swapping places. Okay, so we have the O minus K plus our same phenol alcohol at the end of it. So we have the same starting material, but in basic conditions and the acidic conditions, we get overall kind of the same product, but the difference is whether it's a carboxylic acid or a carboxylate. Overall, same type thing. Okay, that's all we're doing on esters.